The setting up of the color coding can be a bit tricky, and in fact the rules that you put in place here, all of this can actually be done in Excel and then just pasted in, because Excel might give you a bit more flexibility. And you might wonder, well, how do I put the color red into my Excel screen? This is something that we'll help with, but the shortcut is when you're looking at the color selection swatch, you just hold down the Shift button and click the color. And that gives you a color code which can be put into your Excel sheets when you're setting up your color coding, so that when you paste them in, the colors are automatically used. Don't worry too much about that at the moment, because that's probably one of the trickier aspects of setting up GradeXpert, and we are obviously there to help whenever you need it. So as I mentioned earlier, if you want to color code some of your existing data, and we recommend color coding everything, to be honest, you can just let us know what those break-even points are, even if it's done by year level and term or semester. So you can send us even just an email that says, can we please color code your Lexile testing? Anything for our year ones in term one that's, you could even just give us the benchmarks and say in term one, for year ones we expect them to be at level 50, and in term two, level 53, and so on. And our year twos are these benchmarks. We will set that all up for you so that your map of data that previously opened up without colors will come up color coded. And this color coding is applied to all your historical data as well. So if you've got maps at the moment that are not color coded, that have got data from 2019, 18, 17, we can put the color coding in place that will automatically color code those maps when you open them. Even simple things like your A to E results. You can give each one of those values an equivalent color that is not involved in the conditional color formatting. Again, that's stuff that we can set up for you, but when you're looking at your maps and looking at your data in GradeXpert now and in the next few days, just think of everything that can be color coded. Let us know what it is, and you'll probably find the response from teachers is very positive, because as soon as you're looking at a screen of color coded data versus non-color coded data, it is far easier to interpret, to decode, to make decisions on, and so on. Not only that, but when parents look at this information, if you do show it to them, it makes it stand out a lot more as well, although possibly some parents don't want to see this information. In term 3 I'll put a 6 in, term 4. Alright, I'm actually going to clear that formatting, because the other thing I'm going to show you now is what we call calculated result types. And this means that GradeXpert can take any result and convert it to something else. You can have your PAT scale scores being converted to something that says below, at, or above. And then you can use the below, at, or above to look at, for example, the distribution of PAT data. What percentage of students are below the expected level or at or above? You can't really use distribution if you're using a scale score, because everyone's got a different scale score. So you can't say, well, show me how many people are at a scale score of 121.5, because you'll probably only have 1 or 2 out of the whole school. But you can say, show me everyone who's below, at, or above, based on this calculated result. So this is getting into a lot of the nitty-gritty of GradeXpert. Again, this is something that we can set up for you, but the reason we're going through it is so that you understand that the facility is there to take information that you've entered or imported and convert it to something that is perhaps more meaningful. So when I was talking a bit earlier about some schools up in the territory who are taking every single test result and converting it into one of 4 levels, that means you could essentially have a map with every single piece of information, but represented by level 1, 2, 3, 4, or below, at, or above, regardless of what the original score was, because it's much easier to work out where kids are by looking at something that says below, at, or above than trying to figure out, well, is a scale score of 83 good or bad, and so on. So what I'm going to do in this example is I'm going to take the raw score out of 20, and instead of color coding it, I'm going to convert it to a below, at, or above piece of text that on its own is color coded. So to create a calculated result type, that's done against the assessment and that's done on the next available result type for that test. So we've already set up the first result as a raw score. The second one, if you remember, we had our whole list of result types. I'm going to scroll all the way down to the bottom and choose calculated. And here you can see we can sum up results. We can say it's this plus this plus this, or we can take the average of this plus this plus this, or we could take a conversion and we can say, well, this test is out of 20, I want to convert it to a percentage out of 100, or a percentage out of something else. This is really good when you're using weighted values to perhaps come up with a final result at the end of the year or end of semester. So unit 1 is 20% of my total, unit 2 is 30%, and unit 3 is 50%. So you can convert them to percentages as well. But the most useful one is this evaluate and convert, which is almost identical to setting up your color coding, except that the outcome is not just a color, the outcome is actually some text that you might want to display. So let's keep this simple, and let's say if the raw score is less than or equal to 5, then the final result is going to be below expected level. So I'm actually going to show the text below expected level. If I put that on a graph, I want it to show up as a 1, and I want to then show it in red as well on my map. Now I'm going to say if my raw score is greater than or equal to 6, and my raw score is less than 15, then I want it to show at expected level, because if they're between 5 and 15, then they're at the expected level. That shows slightly higher on a graph. And we show that in amber. And the final one is if the raw score is greater than or equal to 16, then I want it to come up as above expected level. Show that as a 3 in green. So we've set this up in a very similar way to the color coding of the actual result, but we've now removed the color coding of the result, and we're saying based on what you type in, show me another column that will be the words below, at, or above in those colors. And I'll show you why that's useful in a moment. I'll just call this level. So when we go back into our map setup of our color coding testing, at the moment we're just showing the raw score. Let me get rid of all that other stuff. But because we've now set it up that it is going to convert that to a level, we now need to tell it that the level needs to be included as well. So we'll just tick level. And by the way, you can also add comments just by ticking the comments box. So what this is saying is, for the reading assessment, we're going to see on the map the raw score that can be entered. We're then going to see the level that's automatically converted and displayed, and we are going to provide teachers with a comment column. So the 6, the 7, the 5, that's all automatically calculating. So if I say a score of 1, it says below straight away, because it went through those conversions and it said, well, if the score is less than 6, then show it as below in 1. 5, 12, 15. Oh, what's happening with 15? Oh, did I make that mistake again? Settings, level. Ah, I did too. That should be less than and equal to 15. So let me go back to that map. I'll just put 15 in again. I'm going to go full screen because I'll put in some. So you can see I've now got all these different belows, at, aboves. That's all pretty useful. And I'm actually going to graph both of those. So you can see here I've got my individual scores, which can vary quite wildly. And over here, based on that data, I've got whether you're below, at, or above the expected level. If I looked at this data to see who's below, at, or above, but I use the raw score, that doesn't tell me anything useful. It tells me how many students are at 15, for example, but because 15 and above is above, I get different columns for 15, 16, 17, 18. This one, however, that is using that calculated result type, i.e. it's converted it or normed it, if I look at the distribution here, I can see how many are below, how many are at, and how many are above. So I haven't had to use this confusing graph. That's my source data. This is my below, at, or above, and I can do this for any assessment across the school. I can do this for NAPLAN, PAT, PM benchmarking, ATE results, and so on. ATE is probably not requiring much conversion because that's quite a straightforward 5-point scale. But if I look at that graph only, it's taking the calculated values and grouping them by the number of students in each level. I can still look at which students they are by clicking on any of these bars. So who are the 4 kids below the expected level? And those are the 4 students who scored 5 or below. Those are the students who are at, and these are the students who are above. And we can even view that as a pie chart. Sometimes that's easier to get the ratios visible.